So last week we left off at 1C. Now we'll pick up at D, because D and E are the displacement versus distance thing. Displacement is the integral of velocity. Distance is the integral of the absolute value of velocity. Right? It makes sense that they're really similar equations because they're really similar concepts. If you have a hard time remembering which is which, distance is always going to be more than displacement. Well, greater than or equal to. And that absolute value bars makes that happen.
Yeah.
So for this one, it gives you the equation for V. Back up at the top. T minus 7 cosine of t from 0 to 7. This is a calculator question. So this is an easy thing to do because you're letting your calculator do it. The question is really, do you remember what to do? So grab a calculator if you need one. X minus 7 cosine of x.
Make sure you...
Yeah, thank you. Make sure you're in radians. And for a multi-part free response question, it's probably wise to put that in for the graph because you're probably going to need it multiple times. If it's just one question here or there, then maybe you type it in each time you need it. But for when we know we're going to need it a bunch, put it in as an equation. Let's see. I don't remember what we... Well, x we could go 0 to 7 for sure. I've got negative 10 to 10 for y. That looks good enough to look at. Okay, displacement. So that would be... Anybody remember how to find the antiderivative? What buttons?
Math 9?
Yeah, math. If you remember math, that's good enough because then you can go look for it. But it is math 9. Okay, on the interval 0 to 7. So 0 to 7 for my limits. And then I could type it in again.
Vars.
But I want to use vars. I want to use a variable. So use the vars button. Vars. Y vars. Y1. That way you don't have to type it in again.
Are you doing the old version calculator?
Vars are the antiderivative.
Vars x upper limit lower limit.
Negative.
I wrote it down.
Displacement, not derivative.
So y1 comma x comma 0 comma 7. And then there's no more work to show than that. Negative 0.246. Is a negative answer okay for displacement? Would a negative answer be okay for distance?
No.
No. So I maybe pause with the negative, but that just means I backed up from where I started. It should mean my velocity is more negative than positive. And I look at my picture and like, well, it's kind of close, but that makes sense. That's why I got 0.24. Total distance, so same type thing, math 9, 0 to 7. Be careful, you can't just turn that positive. That's not the answer. You have to put math num, oh, we got to talk about where that is, I guess. For absolute value, more math. Scroll over to num, and the first option is abs.
Num abs.
Mm-hmm.
I love that.
Abs. And then
you do vars.
Vars
Vars,
y1 dx 0 to 7.
So what was the sequence again? It was math, abs, something.
Math 9 for the integral.
Okay, so,
Num abs.
Then math num abs.
My calculator is struggling over here.
Yeah, that one took a little bit.
There we go. Remember to get correct to 3 decimal places.
That would be the total area from 0 to 7 if you counted the negative area as positive. That's why the absolute value is on there. So we would add up those areas, not do any subtracting. Remember that for free response question, you got 15 minutes per problem, so that allows you time to play around and press math 9, and math num abs, and vars function, y1, all those things. And even for multiple choice, you get 3 minutes per calculator question, so that's time to punch things in. It's not supposed to be, I mean, if you don't know what you're doing, you're going to be rushed for time. But if you know what you're doing, it's not supposed to be a major time crunch anyway. Part F. Is the particle speeding up or slowing down? So what are we looking at for speeding up, slowing down?
Matching signs.
Yeah, signs of V versus sign of A. So we need V of 5 and A of 5.
I mean, I just typed it into Y1 and then went to the table.
And you could go table, you could go value, you could do lots of things. Maybe table is the easiest for V of 5. Negative 0.567. For A of 5, okay, I don't have a formula for A. How can I get A if I know V?
V prime.
The slope, dv dt. So dv dt at t equals 5. And again, you don't have to take that derivative by hand. This is a calculator problem. So do some calculus, second calc, dy dx, and then you can just punch in 5. And it puts the cursor on there, so you can kind of check to see that, yes, it's going down. So I believe that it's negative. So if the velocity is negative, so you're backing up, acceleration is negative, what does that mean in terms of it's speeding up? Justify your answer.
Velocity and acceleration have the same sign.
That's all you need to say. A and V have the same sign. So you're speeding up in the opposite direction, or in the backwards direction, I guess.
Is this test going to have like a lot of open-ended with justifications? Or like how is this test, like it's going to be multiple choice?
That's a good question. I need to look and see. Haven't looked close.
Is this easier or harder?
This test is a whole lot like this little worksheet packet, so I don't know if that's
A whole lot.
good or bad. It's not identical. Don't read too much into that. It's very similar to. Question G. In the interval 0 to 4, at what time is the particle farthest to the left? Justify your answer.
How do we do that again?
Farthest to the left. Between 0 and 4. Let's see. So there's 4. Roughly. So how will I know when it's furthest to the left?
I don't know.
Isn't it when it intersects the x-axis, so it just becomes negative?
So you're on the right track, but I can't even look there because it said 0 to 4. So I got to stop right here. Over here, what does this mean? The fact that this graph is below the x-axis. It means what's negative?
Slope. Or velocity.
Velocity is negative.
Yeah.
Slope's actually positive there.
Positive, yeah.
But velocity is negative. In fact, because the acceleration is positive, that means it's slowing down. Its speed is headed towards 0. But its negative velocity means which way is it going? Left. Over here, it's positive velocity. Which way is it going when it's positive velocity? To the right. So what's happening right there where it crosses the axis?
It's farthest to the left.
It's farthest to the left, because it changes from going left, 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 and then right there it changes right there and heads back the other way. So that intersection is what they're looking for, but they ask it in kind of a weird way. So farthest left would be when V changes, negative to positive. Second calc 0, left bound, right bound, guess. So at 1.571, I think it's pi over 2, but we don't care about that right now. 1.571. All right, part H. What is the average acceleration? Okay, acceleration is change in velocity over change in time. And I'm spelling it out that way for a specific reason. So how am I going to find average? Kind of an important word there.
A-rock.
So this is algebra slope. Algebra slope of what, though? Yeah, v of 7 minus v of 0 over 7 minus 0. That would definitely get me an acceleration, because I have change in velocity over change in time.
And what is the average acceleration?
And it would give me average acceleration. So v of 7, that would be 0. I can do that. V of 0 is negative 7. And that's a safe stop, which should be fine. Like, it's an easily reducible safe stop, but it's a free response question, so there you go. Enjoy your safe stop. It did not ask for units. It did not ask for justify. I'm sure they're just looking to see if you did algebra slope versus calculus slope. But even if you did calculus slope, you wouldn't really know where to evaluate it, because it says from 0 to 7. So it's not a of 0, it's not a of 7. It's v7 minus v0 over 7 minus 0. Okay, that's it for notes today. I'm going out of order, so let's grab the worksheet packet. And basically it's just one long worksheet, so it's not like worksheet 1, worksheet 2, worksheet 3. But Friday was 1 through 5. Today is 6 through 10. And then tomorrow will be 11 through 14. And there's nothing really new in there. The only kind of new thing is that distance versus displacement. That's the only new thing. The rest of that stuff we've done. I put that at the top. And I mean, that's a bunch of you were absent Friday. That's the only new thing from Friday. I mean, there was a lot of notes, a lot of handouts. We've done all of that stuff before. All right, do you have questions from 1 through 5? I ask you to give them a try. Did you try them?
I tried 3 of them.
You would like to answer them school sheet.
I think I did. Are they not there?
Maybe I can find them.
Kristen.
I will look and see. Questions from 1 through 5?
Number one.
Number 1. The velocity of a particle moving along the x-axis is given by,
That.
okay, ugly, but that's why it's calculator problem. For which of the following statements describe the motion of the particle at t equals 1? Okay, moving to the left versus moving to the right. How are we going to know that?
Moving to the left is negative v.
Yeah, so left would be v is less than 0. Right would be v is more than 0. And what about acceleration?
That's the derivative.
That's the derivative. At t equals 1. So I need to find v of 1 and v prime of 1. It's only one question, but it's sort of two questions. So I would probably put that in the calculator. Square root of x minus cosine e to the x. So ugly stuff there, but you got a calculator. Not so ugly that you couldn't do it by hand if you really wanted to. All right, v of 1 from the table is 1.9. I don't care about decimals like I normally would, because I only care about if it's positive or negative. So we're moving right because it's positive. I don't know why your answer choices are A, B, A, B.
Oh.
Now I just need to know what the acceleration is.
Alrighty then.
That's interesting. Can I tell by looking that the acceleration is positive? I don't want to take that chance. It looks close to 0. Second calc, dy dx at time equals 1, 1.61. Again, don't care about the decimals, because all I really care about is positive. So moving to the right with positive acceleration would be answer choice first B. I think I want to look at number 4.
Yeah. Number 4.
Because Miss Murray and I discussed number 4 until we figured it out in our heads together. The acceleration of a particle is given by that thing. I guess I don't need to write it again. There's the acceleration. At what value of t, and then AP Test likes to do this, is the particle's velocity decreasing the most rapidly?
So where's the slope most steep?
Okay,
Or no, that would be
you're on the right track. So where is the slope
of velocity most steep.
of velocity most... Wait, I don't want the slope most steep. I want the slope to be most negative.
Oh, okay.
Because steep and slope both mean derivative. So if you say slope and steep, that's a derivative of a derivative.
Oh.
So you either want the velocity to be most steeply negative, or you want the acceleration to be most negative. Oh, well, they gave me an equation for acceleration. So I'm just looking for where that acceleration is most negative. So it's an easy thing to look for, but the hard part was interpreting this velocity decreasing the most rapidly. So you want velocity going down the most. So not a little bit like that, but a lot like that. So you're looking at slope of velocity, which is acceleration. Well, it's easy now. X minus 10 sine of x. And again, this is the graph of acceleration, so I'm just looking for where it's most negative.
You can just calc minimum.
I could calc minimum. I could even trace. I shouldn't even say that because trace doesn't give you the exact right answer, but because it's multiple choice, you're probably close enough.
You could do value and then type in the answer.
You could do that. It's probably best to find minimum though. That would give you the definite right answer.
You're the one who was asking for all the different ways.
Yeah, I almost said exact right answer, but it wouldn't be exact because it's still rounded to 8 decimal places or however many it's showing here. 1.45, whatever.
7 decimal places.
There's our answer.
1.454.
So there's always several questions that are like that on the test where like the calculation part, the computation part, it's easy, but can you interpret what in the world they mean by velocity decreasing the most rapidly? That's kind of tricky. Anything else on 1 through 5?
5, please.
Sure. Rest. What does rest mean?
0.
What's 0?
The velocity.
But my brain is chained Google.
I need to know where the velocity is 0.
But the velocity is x prime.
Okay.
Do you plug in the answers? Because that's what I did.
You could plug them in, but where are you going to plug them in?
You don't have.
Because you don't have velocity. You have position. So there's 2 ways to do this. You could find dx dt, which wouldn't be terrible.
But it looks like, yeah.
Derivative of sine is cosine. Chain rule gets you 2 pi plus 2 pi. I don't think that's awful. Maybe
You mean
disagree.
you could plug it in?
If you looked at the graph of position, what would you be looking for? Do you know?
Well, you just take the derivative.
But can I answer this question without taking a derivative?
Ooh, minimum, maybe?
Or the flat points on the graph, like
Yeah.
Yeah, because you're looking for where v is 0, you're looking for where dx dt is 0, so you're looking for where the slope is 0. So you can take the derivative and find it that way, but you could also just look for the flat points of the position graph.
Even though we don't get a calculator for this question?
Oh, it didn't say calculator, so you got to do it the long way.
Mm-hmm.
And then you factor out. You can tell by your answers that it's sort of rigged to work out. Cosine of 2 pi t plus 1. So I want to know where the cosine of 2 pi t equals -1. Okay, unit circle experts. Cosine is -1.
At 3 pi over 2. Pi. Jeez.
So that means I want this thing to be pi, because the cosine of pi is -1. So 2 pi t needs to equal pi. Pi over 2 pi is 1. And I guess you could plug them in, but if you're going to use the plug and guess thing, you still have to get velocity. All right, today's assignment is 6 through 10, so let's do number 6 together. And you know not to get too excited when you're only assigned 5 problems, because 3 of them are FRQs. But we'll do one of them together, so that'll leave you 2 FRQs to try. And these are not these are actual problems from the old AP test, so you're getting a taste of it. Particle P moves along the x-axis such that for time 0, its position is given by, be careful, particle P, we know its position. Particle Q, we know it's velocity. So that's a little bit annoying that they're doing this. We better be just paying extra careful attention here. Position versus velocity. Maybe even before I start this, velocity is s prime, acceleration is v prime, and then backwards, if I antiderivative v, I get something with s, and if I antiderivative a, I get something with v. I'm guessing I'm going to need some of those. Probably lots of those. At time 1, the position of particle q is 2. All right, I think they give me that because to get position, I'm going to have to integrate velocity, and it gives me one of the positions, so that will help. Oh, there's also no calculator. Find v of p, the velocity of the particle at time t. Okay, just be careful because we're talking about particle p. We want its velocity. We're given its position. So how do I find velocity? The derivative.
Yeah.
So, and usually, not always, not for sure, but usually the free response questions get more difficult as you go. So hopefully you can get part A of all of them. It's like, oh, that's a pretty straightforward question they just ask. Just take the derivative of x, negative 4e to the negative t, times negative 1. So 4e to the negative t. Derivative of e to something is e to something. Okay, that wasn't bad.
They're giving you a false sense of security.
Yes. I'm trying to give you some points here. Find the acceleration of q at time t. Find all times when the speed of the particle is decreasing. When speed is decreasing. Okay.
That's acceleration prime.
So that means acceleration and v have different signs. Kind of taking this in reverse order here, but so there's my justify. I'm looking for where they have different signs. They gave me v. I need a. Just going to rewrite v, especially with a negative exponent, because some of us, sometimes tricky to take a derivative. Well, some of you are going to do the quotient rule, which is fine, but it'd be easier if you changed it to a negative exponent. So negative 2 over t cubed is the acceleration of particle q. Oh, I made a small mistake on part A. Not even a mistake. They wouldn't count off. They encourage you not to box your answers. The reason is they will look for the right answer. If you box an answer, that's where they're going to look. So it's kind of a grace toward you that don't box anything. Just leave it all there. Make them go hunt for it because maybe they'll find it.
That's what they get paid for.
So try not to box your answer. It's not wrong if you do, but it opens up you to getting a little bit more partial credit maybe if you don't box things. Okay, so there's part of my answer. Find the acceleration.
Where did negative on the 2 go?
Yeah.
Yep, thank you. Okay, where are we speeding up and speeding down? So I need a v timeline and a timeline. They both start at 0 though, so I don't have to worry about less than 0.
Oh. For some reason my brain interpreted where they're all negative.
So velocity is 1 over t squared. What's that mean about the sign of velocity?
It's always positive?
It's always positive. since I'm only plugging in positive numbers, it's always positive.
But velocity is always negative because
You mean acceleration?
yeah.
And then kind of the same reason, acceleration is always negative because you're only plugging in positive numbers.
But there's the negative too.
And the negative on top. So when is the speed decreasing?
Everywhere.
Let's be careful about everywhere.
From positive.
Speed decreasing when t is greater than 0. Again, just fight the habit of boxing my answer. Because I already answered the y. A and v have different signs. Part C. Find the position of particle q at time t. But I have the velocity of particle q. So if I want to get from velocity backwards to position, antiderivative. So I need the antiderivative of velocity, and that will give me position. Although I need something to plug in here. Like I need two limits.
Can't you just take the derivative? The antiderivative?
If I take the antiderivative, I'm going to have
Plus c.
plus c. I can do it that way.
Would they count that wrong?
Nope, because what will I do with that plus c? How will I figure out what c is?
You do that. They aren't asking us to.
I have some information that would tell me what c is. So we can do it either way. Let's do it that way. So the antiderivative of t to the negative 2. Knowing that I'm going to get a plus c in there, and I'll have to figure that out in a minute. So increase the power by 1, divide by the new power, plus c. So negative 1 over t plus c.
And then
But I know that at 1, so that's my generic answer at time t. At t equals 1, yq equals 2. So I can plug in 1 for t and 2 for y to figure out what c is. So c is 3. So there's my answer.
But if you didn't figure out C, would they count wrong for that? Even though they didn't ask for it?
So I'm going to guess.
If they gave us the information?
I'm going to guess the point values without looking it up. This is just a guess. Because I always add to 9. Is probably 2 for the first one. 1 for if you say dx dt. 1 for if you get the right answer. 2 points for part B, and then probably 3 for part C. So they probably give you a point for recognizing you have to integrate. They probably give you a point for your final answer, and then that middle point is either you figure out what C is, or you do it from 1 to T and fill those in. So there's multiple ways to do that. But they would account for that. Show everything, do everything you can, because maybe you sneak a point out of that, even if you don't really know what's going on. You at least know, well, I got to integrate velocity to get position, so
better to do more than less.
I'll write that down and hope that I get a point. And if you get 1 point rather than 3 points, or 1 point rather than no points. You do that a few times, maybe you go from a 2 to a 3, or 3 to a 4, or 4 to a 5. So keep fighting for every point. All right, as t goes to infinity, which particle will eventually be farther from the origin? So that means I want x of p as t goes to infinity, and I want x of q. These are limit questions.
Yeah.
As t goes to infinity. So x of p isn't bad because they told us what it is. So if I plug in infinity, no calculator, 6 minus 4e to the negative really big number, e to the negative gazillion.
That's over.
That's 4 over e to the gazillion.
That makes it a really, really small number.
So so the p particle, eventually, it doesn't end up at 6 because it never gets there, but it's headed towards 6. And that's what they mean as t goes to infinity. So there's my p particle. My q particle, it gave me
we figured it out.
We figured it out. So this is, part D definitely hinges on part C.
But isn't continuity, so even if you made something up for part C, if you
it has to be what they say is non-trivial. So if you get an answer for part C that's like sort of correct, then they'll carry it through and check your work and see how you did. If you get something like 0, they're going to be like, all right, we're not going to carry through a dumb answer. So if you make a small mistake that they can figure out, then they carry it through. Here's another one that's easy, because if you plug in infinity, you're going to get 3.
So x of p.
So particle P is farther away.
As x goes to infinity. Or as t.
As t goes to infinity, yeah. Yeah, so literally zoom out on that problem for a minute.
Yeah.
I would hope everyone would get part A.
Yeah.
2 points. I would hope we would get part B. 2 more points. And then things get a little dicey after that. But if you're sitting at 4 out of 9,
It's not too bad.
4 out of 9 almost every year is going to get you a 3. And then maybe you
It's 44%.
maybe you sneak out a point from one of the others with enough work showing, and maybe they see something that they like, and you get 5 out of 9. And 5 out of 9, you're sitting at a 4. So, you got to fight for every point, and basically your goal is to walk out feeling like I got 4 out of 9. I got a 3. And maybe I snuck my way into a 4 or a 5. That's where probably most of you are. Some of you aim for a 5 and get your 5. But for a lot of us, it's like, fight for every point. This was a hard question, but if you got half of it right, you get your credit. So that's the message the whole second semester is: fight for every point, hang in there, show your work, get some points. All right, your job is 7 through 10. Try those. We'll look at them tomorrow.